Today's lesson is about parabolas and several different pieces of information that we can put together helping us graph parabolas. Now, your online graphing will work a little bit differently than what you see me try to sketch out here online. And a lot of times you are trying to identify, though, the particular information that I'm going to help you identify, and then that will help you choose the correct graph. And we can also look at how that's going to look in your homework. This information here, you might want to take a picture of it or just make a quick note, particularly those words that are in bold, because that's what we're going to do. And then I think my next slide actually tells you how to find that information. So just get the key words off of that page and be good to go. So axis of symmetry, vertex, maximum or minimum, and then graph the parabola. Here's your next page going down here on the left. That is key information that you'll need as we go through all of our examples. Actually, we will follow this information. This opposite of b over 2a, I mentioned that I think in our last video, but that's kind of like part of the quadratic formula if we didn't have to deal with the square root. And that is a line. Make sure it's not just the opposite of b over 2a. It has to be x equals. The axis of symmetry is the equation of a line. And so we get the entire equation here. Whereas the vertex is just a point and has values in it. So let's start to work one of these out then. I'm going to start off with x equals the opposite of b over 2a. So I know there's a lot of 2's here, but this is the a, -2, and this is b. So I did the opposite of b over 2a. And so then I'm going to simplify that, and that is -2 over -4, which is 1/2. So my axis of symmetry is x equals 1/2. Now the vertex, what happens with the vertex is the very first point of the vertex, or the very first value that you want to put in your vertex, is the same. So you can just copy that over to the beginning of that next one, and we can write our 1/2 down again. And then to find the y value of the vertex, what you want to do is to find this value is you're going to take this 1/2 and you're going to plug it into the equation. You can see on the left here it says f of the opposite of b over 2a. Well, I found out the opposite of b over 2a was 1/2. So what I'm going to do is find f of 1/2, which means I'm going to plug 1/2 into that original equation. So I get -2 times 1/2 squared plus 2 times 1/2 plus 3. And you want to simplify that. Of course, one way that you can plug things in really accurately and carefully on your calculator is to use this store feature. So what I'm actually going to do is 1/2, then I'm going to click STO. It's just STO. It's down here on the bottom, or just below that on button on the lower left. And I'm going to hit, and it stands for store, but a lot of times I will say STO because that's what the key says. And I want to store that value into my variable x, and then hit enter, and it simply shows me a 1/2. But now every time I hit x, it knows that that value is 1/2. And don't worry about clearing that out. Even if you've never used it before, your calculator already has a value stored there. I think it comes with a 0 stored there. So now I can just type in this as it was, and that's a little bit easier than me typing in all those fractions. So I get -2x squared plus 2x plus 3. But since my calculator knows the x value is 1/2, it will calculate that for me, and I get 7 over 2. Same thing as 3.5, but it just does that for me. So 7 over 2, and then 7 over 2 is what I want to say the rest of my vertex is. Now certainly both of those could be just decimals. You don't want to round unless your instructions tell you to round, but I could have put 0.5 and 3.5, same thing. So now, which direction does this open? You have to look at your first number to determine if it opens up or down, and that also then lets you know if it's a maximum or minimum. So my very first number was -2. A is -2. Since A is less than 0, this thing opens down. So I just think, okay, A is negative, so, you know, like negative people frown. I know it's a stupid little trick, but so you go. Since it's opening down, that means that that vertex is the highest value, and therefore it's a maximum. So I haven't fully graphed that one, but that's the information that we have to consistently find so that we can graph it. Looking right here on this one, we're going to still go through those things. Axis of symmetry, we often write AOS, and it is x equals, it's got to be an equation, x equals the opposite of b over 2a. So that's -10/2, which is -5. Now, I can't do things very well with this online graphing thing I've got here. I will bring up a homework problem in a minute, but that means that at -5, and this was counting by 2's, so right here at -5, there is that equation of this like invisible line here is going to be the fold line for my parabola. Now, somewhere on that line, there's a vertex. So when I do the vertex, I just start with my -5 here. Again, I just copied that into that spot. And then to find the y value, I want to find f of -5. I want to take -5 and I want to plug it back into my equation. So what I'm going to do, I'm going to bring up my calculator again, and I'm going to store -5 as my x value, and then I can just type that in. It's the fastest way you can go about it. So -5, store x, enter. So now I've stored it in there, and now I can type in this just as it is. So x squared plus 10x plus 23. And that equals -2. So that is the value that I put right here. So now I have a vertex of -5, -2. That means over here on my graph, I already know this line is at -5. If I go down to -2, that's my vertex. What direction does this open? Is this a maximum or minimum? I'm going to look at my A value right here. And since that value is positive, you know, positive people smile. That means this thing is opening up, which means that vertex is a minimum. Now I'm going to go ahead and finish graphing this, but it is a little bit different on the online one. So for what you're doing, we'll have to look at the homework and see how that applies. So what I do is I use A is not a slope, but it's a little bit like a slope. I can use A over 1 like a slope to find one more point. You can't use it over and over because it's not a steady rate of change. But up here, since A is 1, that means I can go up 1 and over 1. And I have just found another point. That lets me know how wide this is because in general, it's not going to open very quickly. But now that's not the only thing you can do. Here's another thing you can do. I'm going to put and reflect. Your other option, of course, is just plug in a number. And for many students, that's what they like. So you pick an x and then find a y. And of course, the easiest x to pick is to pick 0 unless that was your axis of symmetry, and then it's not going to do any good. But if I pick 0 here, this thing ends up being 23, which is off my graph. So picking 0 doesn't really work very well for me, but let me bring up the calculator and show you other things you can do. I've got this. I can just change my x value and quickly plug in numbers. So maybe I want to plug in -2. See, -2 is right here on this graph. So if I plug in -2 and then I store it into x, then I can just go back up and copy that equation that I did before, and it will recalculate it for me. So if I plug in a -2, it equals 7, and that will fit on my graph. So at -2, then I can go 2, 4, 6, 7 right here. And you can see that that does fit the curve. So I'll just kind of add that to that. I picked -2 and I got 7 and I put that on there. But this idea of reflect, anytime you know where one point is, because it's symmetrical, the other point is the same distance on the other side of the axis. So here I'm just going to go out to right there and know that I have another point. Now, I wish that I felt at all confident that I would be able to connect all those dots in a nice smooth curve, but you've watched enough of this online stuff to know by now it's going to be a wreck. And I've definitely done worse than that before, and we're going to use that official approach of if you miss the dot, make it bigger. So that's what that graph looks like. All right. This is exactly what some of the instructions on one of your homework problems says. So we're going to go through this and just know that this is the kind of instructions you're finding. Find the vertex. It actually didn't ask us for then the axis of symmetry, but I still have to do that work because the vertex starts at the opposite of b over 2a. So I'm going to go over here and say the opposite of b over 2a. And that ends up being -14 over -2, which is 7. So I know the first number in my vertex is a 7. Then I need to plug 7 back into my equation so I can find the y value of the vertex. 7, store it into x. And then I want to type in my equation then -x² plus 14x minus 47, and that equals 2. So when I plugged in a 7, I got 2, and that 2 then is the y value of my vertex. So if I were going to put that over here, let me just go ahead and put the vertex on. 7, 2, 2, 4, 6, 7, and then 2. It's going to be about right there. Now, is this a maximum or a minimum? I want to go back here and look at A. Because this is negative, I know it's opening down. And since it's opening down, that's a maximum, okay, because that's a high value. Now it says find that value. The maximum is y, and it's at x. You just got to remember that. At x is y. At before is alphabetically and x before y alphabetically. So what is that maximum value? That maximum value is 2. That's as high as this thing gets. Okay, find the range. Well, because I know this thing is opening down and that high value right here is at 2, then the range, which has to do with y values, is everything below 2 and up to 2. So that's going to be -infinity all the way up to 2. That should have been closed at 2 if you actually use the value. Now, on what intervals is the function increasing and decreasing? So I'm going to separate this into two things. We have increasing and decreasing. So travel this from left to right. Remember, increasing and decreasing has to do with lox intervals. It comes from the left, it is open, and it's about x. So the x value is what I'm doing. I'm coming from the left, way out here to the left, so that's -infinity. And as I'm going along, I am increasing until I get to this point. I know the y value, that is 2, but increasing and decreasing has to do with x. So what was the x value of that point? 7. So from -infinity to 7, it is increasing, and they are always open. Lox, the O is for open. And then it is decreasing from 7 as it travels to the right. So now if you look at this, I'm going to erase this, but come over here. What we just did is we just separated x-axis essentially by that vertex. We said from negative infinity to 7, it was increasing, and from 7 to infinity, it was decreasing. So that's how that worked, but you have to answer about x. And then graph the function. So now I need to finish a graph. It will be different online as we talked about it, but I can plug in a 0, but man, that's going to be negative 47. I can't get that on the graph. So far down. So what I'm going to do is, again, you can plug in any number you want to. I'll bring back up the calculator. 4, store into x, enter, and then I'm going to go back up and let's calculate it with the positive value. Okay, so at 4, it gives me negative 7. So I can put that on the graph. 2, 4, and then negative 2, 4, 6, 7. And I know that I can go to the other side of it and get one that's symmetrical. So it didn't ask me to put it on here, but that axis of symmetry is running right down through here. It is the equation x equals 7. It goes through the maximum, which is 7, 2. And then my graph does something kind of like this. One other thing you have to do, and we talked about this in a previous video, is take the function that's given in its standard form and rewrite it in vertex form. These equations here, I've already given us a vertex. We've actually already found those vertices on another slide. But if we have them, then we should be able to write this in vertex form. Because vertex form is a parentheses x minus h, close parentheses, squared, plus k. And hk comes from your vertex, and a comes from the beginning of your problem. So if I want to write this first one in vertex form, f of x equals, now the a value for this problem was negative 2, and then x minus h, fractions would have been great, squared plus k. And it's done. Now, if you look at the Pearson videos, I think they have a much longer, or the Pearson Show Me an Example, it's a much longer process. I don't know why they do it that way. F of x equals, now the a here is the understood 1. It can still be an understood 1. You don't need to rewrite that 1. So I have x minus negative 5, which makes that x plus 5 squared, and then minus 2. Now, having that lets us very quickly identify graphs and find parent functions and use transformations. And that's what our next slide is identifying graphs. You'll have to do some of that on your homework, and then I will bring up a homework example to particularly look at. What we know on this one is the parent. Let's just consider what the parent is. The parent function of a quadratic is y equals x squared. So this indicates that that vertex has been moved to the left 3. Oh, there's number 1. Moved to the left 3. That's the only one that's exactly like that. I don't want to do anything with multiplication until the end because those are usually a little bit harder. So let's do anything without that first. This one then is just moved down 3. Okay, down 3. And that appears to be this one. So this one is number 3. So we have done this one and we've done this one. Let's look at number 5 here because this is shifts and then reflected down. So this one is going to move to the right 4, up 3, and this negative in front means it's going to be open and down. So I've got to find a vertex that's to the right 4 and up 3, and then the whole thing opens down. That's got to be this one, right 4, up 3, and it's opening down. So that one is number 5. Now this one has moved to the right 3. That's the only thing that happened to it. So So this appears to be number 6. Here I have one that has moved to the left 3. Everything inside there with the X, remember the X lies. That one is to the left 3 and up 4, but because it's got this negative in front, we know it's open and down. So left and up and open and down. So this one is number 7. So now we're left with the ones that have the multiplication in front. But as I look at this, here's a 2, a negative 1/2, and a 2. This one has to be opening down. It is the only one left that's opening down. Now, I can tell also that it has moved to the left 3, up 4, and what the 1/2 did in front is change how wide it appears or how tall it appears. So out of the ones we don't have labeled, this is the only one that's still opening down. And it's very hard to see the change in width, okay? That's why I want to save those until the end. That just has to do with kind of how close zoomed in you are. But this definitely has moved to the left and up, and it's opening down. So this one is number 4. So now I have 2 graphs left, but they have vertices in very different places. So even though the widths look the same, what I want to do is look at where that vertex is. On number 2, this vertex has been moved to the right 4 and down 1. Oh, that's got to be this one then, because the other one has moved to the left. So that one's number 2, which of course means this one is number 8, because it has moved to the left 1 and then down 4. So you can use that vertex form to really help you identify the graph, and that's why you want to be able to rewrite something in vertex form. So now let me see if I can bring up some homework. The vertex occurs at, so I need to do the opposite of B, so that'd be positive 12 over 2A. So that'd be 2 times 1. So positive 12 over 2 then is 6. So my very first value is a 6. But how do I find the second value? I need to take that 6 and plug it back in. What I'm going to do is take 6, store it into X, and then type my equation. X squared minus 12x plus 32. And that gives me negative 4. So when I plugged in a 6, I got a negative 4. Close parentheses. Okay, find the equation for the axis of symmetry. It has to be an equation. It's always x equals. And it's x equals, and then you use the same number you used for the x of the vertex. Same thing. Determine if it's a maximum or minimum and find its value. Well, let's look at A. A is positive, which means this one is smiling, so it's opening upward. If it opens upward, it has a minimum value. The minimum value is the y value of that vertex, so it is negative 4. So now we have to graph it. This is particularly what I wanted to show you. So you always want to enlarge your graph if you can, all right? And take your shape. So over here, I know this thing opens, this is a parabola, it's opening up or down. Whether or not, even if it opens down, this is the shape you're going to pick. Okay, so now you've got to put it on there, and you can try, hopefully you can get it at the right place, but even if you can't, you get it on there and then you can adjust it. So I'm going to try to get my vertex at, I believe it was 6, negative 4, but I can't even hardly remember that. So, and then I have to find another point. So if I take that equation, which you can just see over here in this area, and if I plug in a 0, it's 32. So that's too big to plug in. So I'm just going to pause for a minute and bring back up my calculator and plug something else in for x so I can find another point. So I got my 6, negative 4. I need to plug in something else. One thing that's usually pretty handy to plug in is a number that's close to this x value. So like if I plug in a 5, it'll probably give me a number I can graph. I could plug in something else, but 0, you know, is too far away. the closer they are to the vertex, the closer the numbers are going to be the same. So if I take 5, store that into X, now please tell me what that one equals. Okay, so when I plug in a 5, I get -3. I should be able to graph that. So I'm going to take my other point and go to 5, -3. Now, if you need to, you can click on one of those and you can see up here exactly what it said. So if you don't get it placed right in the first place, that's totally cool, because then you can just edit it up there. So I had 6, -4 and 5, -3. So I know this one's okay, but just pretend. Okay, I'm just going to clear it. And I'm just going to take this and I'm going to randomly put this sucker on here. Okay, I know this isn't right at all, see? But that's where editing the coordinates can kind of help. So this is my vertex I've selected. I can go up here and click Edit Coordinates, and then you can just type them in if you have a hard time doing it. So that was at 6, -4. Submit. And now click the other one, Edit Coordinates, and I can put that one at 5, -3. Okay? So whether or not you can control it well enough to get it in the exact right place, or you just need to put it on there and then edit your coordinates. And then what you want to do is save it. And once it's over here in blue, then you're good to check your answer. Okay? So I just wanted to share that about how to work on the homework, and that's going to finish up this video. Get in touch if you have any questions. Thanks.